Alright, students, we solved selected questions of exercise 2.7 in the class. Then I have shared the list of selected questions for exercise 2.8. You can give it a try and then we will discuss that in a query session. For exercise 3.1, we covered some of the properties of derivative or differentiation that we do. We said that if you find the derivative of a sum, it will be the sum of two derivatives, or if you find the derivative of difference, it should be the difference of two derivatives. The derivative of a constant multiplied with a function should be the constant multiplied with the derivative of function. Derivative of constant is 0, derivative of x is 1. So then power rule dictates that derivative of x power n is n times x power n minus 1, and that way derivative of square root of x is 1 divided by 2 times the square root of x. We have established these things till now. We are trying to use them for solving questions from 3 onwards. The questions from 3 to 34, there are multiple parts. They say differentiate the following questions. So question number 3 has a function g of x equals to 4 times x plus 7. When we are going to take the derivative of it, we will apply derivative on 4x first and then derivative on 7. So it's a constant multiplied with a function like this case. So we take 4 out, apply derivative on the x only. The derivative of 7 is a constant, so derivative of 7 is 0. Now derivative of x with respect to x is 1, so that becomes 4 times 1, which is 4. So derivative of g function is represented as g prime of x. We say g prime of x is 4 times 1, which is 4. In question number 5, the equation is f of x equals to x power 75 minus x plus 3. It's a polynomial. We apply the same strategy. We take derivative of x power 75 with respect to x minus derivative of x with respect to x plus derivative of 3 with respect to x. We know 3 is a constant, so derivative of 3 will be 0. Derivative of x is 1. We know that thing. Minus on x power 75, we will use the power rule. So the derivative will be 75 times x power 74. The final answer would be the derivative of f of x should be written as f prime of x. It will be equal to 75 x power 74 minus 1. We move to question number 8. It's a bit tricky. It says f of t equals to t power 3 plus e power 3. Now we are not supposed to be taking derivative of e power 3 as per the power rule, because e power 3 is a constant number. E has a value of 2.718 something. It's an irrational number, and you raise it to power 3, it's again a constant number. So the derivative of e power 3 is 0. We don't need to apply any power rule here. Please do not say that the derivative of e power 3 with respect to x is 3 times e power 2. No, e power 3 is a constant number, so the derivative of it would be 0. Pretty much the same as the derivative of 2 is 0, derivative of 100 is 0, derivative of any positive negative number is 0, right? So the only term that we need to take derivative of is t power 3. So derivative of t power 3 with respect to t is 3 times t squared plus the derivative of e power 3 is 0. I have solved question number 15 here because it has a term square root of x in it, and I have written the derivative of square root of x on the board already, so I want to make the best use of it. I want to utilize it. So y equals to 2x plus square root of x. If we need the derivative of y, we will just apply prime on it. So y prime will represent the derivative of y function, which will be equal to, we keep 2 out, we apply derivative on the x plus derivative on square root of x. So derivative of x is 1, so that would be 2 times 1 plus derivative of square root of x is 1 upon 2 times the square root of x. So the final answer would be 2 plus 1 upon 2 times the square root of x. That would be y prime. Question 10 says r of z equals to z power negative 5 minus z power half. This is a negative exponent and a fractional power, so I thought it's worth doing. We take derivative of z power minus 5, that becomes minus 5 z power minus 6. So if you subtract one from a negative number, it becomes more negative. the derivative of z power half will be, you take half in the down in the multiplication, and z power half will be subtracted by 1, so that will be a negative half. You can write it like this if you want. That's acceptable answer till this point. Or if you bring z power negative 6 in the denominator, that would become z power positive 6. And if you bring z power negative half in the denominator, that would become z power square root of z, the positive square root it would have. So this would be minus 5 divided by z power 6 minus 1 over 2 square root of z. This is kind of a fancy way of writing it, so it doesn't matter which where you stop and which style you go with. All are acceptable. In question number 12, we have t power minus 3 by 5 plus t power 4. Again, it's a fractional power. I thought maybe you would mess it up when you are subtracting 1 from it. So we take the derivative, we bring minus 3 over 5 down in the multiply. We subtract 1 from negative 3 by 5, and the result of that becomes negative 8 by 5. You can make these calculations at home and see that really it works that way. The derivative of t power 4 is so obvious, it's 4 times t power 3. In question 14, we have r of t equals to a divided by t squared plus b divided by t power 4. In order to do the derivative of this, we write it in form of negative exponents. So we write it like a times t power minus 2 plus b times t power minus 4. This is another way of saying the same thing. Now it is very easy. We take derivative of the first term and then derivative of the second term. A is multiplied with the variable, so we take a out. We take derivative of t power minus 2, which becomes minus 2 times t power minus 3. We take b out because it's a constant multiple. We just take derivative of t power minus 4, which becomes minus 4 t power minus 5. We can leave it there, or if we want to make it more sober, we can write it like minus 2a divided by t power 3 minus 4b divided by t power 5. Now, after question number 14, 15 and 16 are similar, but there's a problem with question number 18, which has e power t in it. There was a similar kind of problem with question number 7. It had minus 2 e power t. So I saw e power t and I just kind of chose to ignore that part, and I did all the other parts and did not touch this one. The similar way, question number 21 also has e power x to it. For now, we don't know the derivative of e power x or e power t or e power any other number, e power any other variable, right? So we are not attempting those parts for now. We'll be doing them immediately after we are done with the other parts. In question number 17, you have 1 over square root of x plus 4th root of x. So 1 over square root of x can be written as x power minus half. 4th root can be written as x power 1 over 4. So these both have fractional powers to them. Further, you can just simplify them, take the derivative of them. It's easy for you, so do it yourself. If you get a question that has one polynomial multiplied with another, or it has one variable multiplied with another variable, you can just simplify the multiplication first. So x power 3 multiplied with x is x power 4 plus x power 3 multiplied by 3 is 3 times x power 3. Now it's a very simple polynomial. You can take derivative of it yourself. Then if it is 2t minus 3 whole squared, the idea is to expand the square first and convert it into a simple polynomial, then take the derivative. You use this a minus b whole square identity. So a square minus 2 times a times b plus b square. Simplify it, you will get 4t square minus 12t plus 9. It's a very simple polynomial. Just take the derivative. The similar way, question number 22 has s of r equals to 4 pi r square. Now only the variable here is capital R. The 4, the pi, these are constant numbers. So you just leave these constant numbers out. Take the derivative of r square. The derivative of r square is 2r. So 2r multiplied with 4 pi will be 8 pi r. As simple as that. In question 24, we have an algebraic function. We need to simplify it the way we simplified the rest of the questions. So it's square root of x plus x divided by x square. So this x square should divide both of the terms independently. If we divide square root of x with x square, this got power half, this got power 2. So it would be x power half minus 2, plus this got x power 1 and this is x power 2. 1 will get subtracted from 2. I'll be left with 1 over x, or x power minus 1. So if you get till this point, it's very simple. You got to use the power rule. This power minus 3 by 2 will come down in multiply. X will be raised to a new power, x power minus 3 by 2 minus 1, which will be x power minus 5 by 2. This power minus 1 will come down in multiply, and the previous power will be subtracted by 1 and will become x power minus 2. If you leave it here, nobody would kill you, and if you further simplify it to this more appropriate form, that's even better. Then question number 29 says f of z equals to a plus bz plus cz squared divided by z squared. Now you got to use the same principle, divide every term with z square. So we got a divided by z square plus bc divided by z square plus cz squared divided by z squared. Now z square got cancelled in this term, we are left with c. Here we got b times z power minus 1, here we got a times z power minus 2. You apply the simple power rule, you keep a out of the discussion and take derivative of z power minus 2, that will be minus 2 z power minus 3. You keep b out, the derivative of z power minus 1 will be minus z power minus 2, the derivative of c will be 0. Simplify it into this format or leave your answer there, both are acceptable. Then after question 29, there we see question number 28, and it has k of r equals to e power r plus r power e. It again has e power r exponential function. We see question number 34, it has y equals to e power x plus 1 plus 1. So now that's a little bit too much. We are getting so many questions in e power x format, so it's only fair that we discuss the derivative of exponential functions now. So we talk about the derivative of a general exponential function, that if you have b to power x, whenever you have a fixed base, a constant number as a base, and you have a variable as a power, we call them exponential functions. I hope you recall from chapter number 1 functions when we discussed it. So the derivative of an exponential function with respect to x will be b power x as it is, the original exponential function as it is, times natural log of the base. Okay, you can verify this. Now if we put the e power x there instead of b power x, we will have e power x same and natural log of e. We know natural log of e equals to 1. So now the derivative of e power x will be e power x itself. You can verify these results, and if you need it, I will make a short video about the derivation of the derivative of b power x or derivative of a power x or e power x. Okay. Now that means that when you find the derivative of e power x, you get e power x in return. It means e power x is a function that has the same slope as the height of the function. So as the height progresses, as the height gets bigger and bigger and bigger, the slope of the tangent line at those locations also becomes bigger and bigger and bigger. It stays the same. E power x always comes in those kind of distributions, in those kind of models, mathematical models, where we say that the rate of growth or rate of decline is directly proportional to the original population size. Okay, so it means the bigger your population is getting, the rate of growth is increasing that way. It's only proportional to the size of the population. It's not the half of the population or the double of the population or something. It's directly proportional to the original size of the population. So you are increasing the population, by what factor the population is increasing, the growth rate is also increasing that way. So we say the derivative of e power x is same e power x. it means you cannot change it. It's like some of the people for which you think, okay, I will change him. No, the only way you change him is to change him. You can't change him. So some of the people are like e power x, they are not prone to change, nothing can change them. So now we are attempting all these questions which have e power x in them. So question number 7 had f of t equals to minus 2 times e power t. So we keep minus 2 out of the discussion. We take derivative of e power t. So the derivative of e power t with respect to t should be e power t. So we get the same answer, minus 2 e power t. Then we have question 18. W of t is the square root of t minus 2 times e power t. The derivative of square root of t is 1 upon 2 square root of t. I hope you remember it. If you don't, just go memorize it. Okay. Minus, we keep 2 same. The derivative of e power t will be, yes, e power t, the same. So that's the answer. Question number 21 says y equals to 3 e power x plus 4 divided by cube root of x. So if you bring cube root to the numerator, you will have 4 times x power minus 1 over 3. You know the derivative of it, it will be 4 same. Minus 1 over 3 will come in multiply, so that will be minus 4 over 3 x power. If you subtract 1 from minus 1 upon 3, you will get minus 4 over 3. You are clear about this term? Just we need to discuss this term, 3 e power x. So we keep 3 the same. The derivative of e power x is same e power x. So that's the answer. Now something interesting in 28 is that k of r is e power r plus r power e. Now r is the main variable. So the derivative of e power r is e power r, we know that. The derivative of r power e, now we are not cancelling r power e. R is not a constant number, r is a variable. So if I have r power 3, the derivative will be 3r square. If I have r power e, the derivative would be e r power e minus 1. If you leave it there, that's perfect. If you further dig into it and solve it more, that's even up to you. Last question, question 34 says y equals to e power x plus 1 plus 1. So I split it and write e power x plus 1 as e times e power x, because when bases are same, in multiplication power should be added. So e power 1 times e power x will be e power x plus 1 plus the one that we have in the equation, the later part. We are taking the derivative. E is a constant number, we keep it out. The derivative of e power x is same e power x plus the derivative of 1 is 0. So now my answer is e times e power x. If I merge it, it will be e power x plus 1.